Hello everyone, let's think about this problem. Find the volume of the solid that you get if you rotate the region bounded by y equals x cubed, y equals 27, and x equals 0 about the y-axis. First, sketch a cross-section and find the area. So, I'm looking at the curve y equals x cubed. It would be awesome if you knew instinctively what this looked like, but if not, there are lots of tools online that can graph it for you. I'm also looking at this line, which is the x-axis, which is y equals 0, and this line, which is y equals 27. And so I'm taking this region and I'm rotating it about the y-axis. Now it's easiest for me to think about slicing this in terms of y. So I'm going to be trying to set up an integral that involves dy because y is what's changing. Another thing to point out is I can already tell that this is going to start at y equals 0 and end at y equals 27. So my goal is to find a cross-section. A cross-section is going to be a circle with a radius that looks like this blue thing I'm just looking at. Right away I see that that radius is equal to x. So if I look on this curve from this point right here from the y-axis to the curve, that length is exactly equal to the x-coordinate of the point on the curve. If I were just looking at this cross-section, I could say, the area is x squared. There's a problem with that. This is an x and this is a dy. Those aren't going to play well together. So I need to solve for x in terms of y. Well, y is equal to x cubed. I can take the cube root of both sides, or I can raise both sides to the 1/3 power, however you think about it, and I can get y to the 1/3 equals x. That's awesome. I can plug that back in for x. The result of all that is that my integral is going to become, the area function in terms of y is going to become a equals pi y to the 1/3 squared. So the area is pi y to the 2/3. So I'm looking at the integral from 0 to 27 pi y to the 2/3 dy. You should keep going. You should use the fundamental theorem of calculus and get a number. But in the interest of time, I'm just going to stop here and say that this is how you set it up. I think from here you can integrate it, so we'll talk about that another time.